Wave of Comet is kind of one of the titles. We also have some other Prince Comet stuff, but whatever you call it, we're here today to talk about Comet, and I want to thank the panelists. Got people from all over the world, so it's really great. I want to do a special thanks to Google for allowing us this meeting, providing the food. Stephanie in the back for organizing the food, the room. It's been very, very helpful. Not just for this event, but many events. Silicon Valley Web Builder for Best for having us back again this year. And like I said, the panelists again, many of them travel from a very long way. Vibrate your phones. A lot more fun that way. So we don't want to listen to them. I had a better picture, but anyway. So one of my principal architect at one of the Bay Area financials, and I run a couple of user groups. And then I'll let the panelists introduce themselves as they come up here. So Ted from IceFaces. Ted, you want to tell a little bit about something about yourself? Where'd you come from? Whatever.
Okay. Maybe easier for me to talk about IceFaces. IceFaces is an AJAX framework for Java server faces. It's all Java-based. Includes AJAX Push, or also known as Comet. And I'm the architect of IceFaces.
And a real nice guy. Thanks, Ted. Alex.
I'm Alex Russell. I used to be project lead for Dojo. It's under much better management now, thanks to Pete Higgins over here. And I had the dubious distinction of coining the word Comet, so you can blame me later. I now work on Chrome Frame.
Dylan.
I'm Dylan Schiemann. I'm the co-founder of Dojo with Alex and David Chancellor. And I'm the CEO of SitePen, and I run a site called Comet Daily.
Michael.
My name is Michael Carter. I'm the founder of the Orbited project, which is a Comet server that's been out for a few years now. And one of the principles that I believe in is building very simple interfaces and putting as little functionality into the bottom layer as possible to make it work, and then building out layers on top. And so Orbited actually provides a TCP socket that works in the browser using Comet. So we're sort of tunneling TCP over Comet, and it lets you build any protocol on top.
Great.
Hi, I'm Greg Wilkins. I wrote the Jetty servlet container and HTTP server. And I guess in recent years, I've been putting a lot of asynchronous features into it to help a lot of the scaling that is needed for servicing Comet connections, the hanging gets, as the Google guys call them, or long poles, as other people call them. I also work on the Comet D project with the Google guys, and it's now also does jQuery as well, which is a Comet framework. Yeah.
Very good. And my kind of tie to Comet is very much involved with Comet D, and I've done a lot of work with Greg, and been really pleased with the relationship with WebType and working with them. So good. One thing that I do want to take a brief second is to thank all the panelists. So one of the things projects that I'm working on my side is a book, and each of these panelists actually provided a little bit of content for that book. So that'll be coming out in March, and you'll hear more about it later. But I did want to take the opportunity, since they are here, to thank each and every one of them. So special thanks. All right, so I wanted to do very, very briefly, ask all the panelists kind of what is Comet. And for me, my answer is very simple: pushing data to the browser. That's really all it is to me. So various people have various opinions about whether WebSocket's what it is. A lot of people say that Google Wave is not Comet, whatever. But I'd like to kind of start here with Greg and see what Greg. Do you have like a one-liner? What is Comet? I'm sure
I'd agree with that definition. It's pushing data out to the out to the web, I guess, not to the browser. So inverting the client-server relationship and be able to push things to a client, be they be in a browser or even in a rich desktop going across HTTP.
Michael?
I think Comet is a very crude set of techniques for being able to push data to a browser.
I like that. It's kind of a hack, right? That's I think what Alex or someone said last year. Dylan?
I would say it's a collection of hacks and techniques, servers, clients, protocols, transports, etc., for making things faster between the server and the client.
Wow. Alec, or who is Ted? I really need to be in front of these guys. But
We've got a bunch of different terms, AJAX push, Comet, Reverse AJAX, but we're all referring to the same thing, the ability to push data from the server to the browser. And it's a tremendous change in what we can do with the web, because now we can make applications let people communicate with each other, whereas before the web is almost like a static printout on your screen.
What they said.
I intentionally didn't steal your phrase, which is low latency data transit, is what Alex used to always say.
all right, so here we have it. Alex, what? Oh, we'll put this up here. Oh man, I'm not a good typer. What they said. All right, very good. So that'll go up on SlideShare eventually. So where are we at here? How do we make this thing play?
Did you forget to do your slides in advance, Kevin?
Dude, I did the slides like 20 minutes ago. All right, so we finished out this slide, right? I meant to email you guys and ask you ahead of time, but anyway, so let's start the next slide. No. Here we go. This is how I start my
Real-time, low latency slide development.
Yeah, massively scalable. Anyway,
Yeah, I think the names on the bottom are wrong.
I will apologize that I did take a few pounds off myself, and I gave them. Looks like I gave them to Alex actually, but these are not horizontally scalable correctly. But anyway,
we
last
picked
year
up 3 committers.
Yeah, I need to open source this work, but anyway, we all know about that, and these guys especially. So last year we had a lot of problems with people kind of asking questions, and it was kind of a "Hey you" with the blue shirt. And if any of you saw the video from last year, it was so incredibly horrible that you couldn't tell the difference between me and Michael. So those watching the video really, so here, this will help you with names and.
You do realize
and what they do.
the names are wrong.
Greg is right.
Anyway, I'll fix that while these guys answer the first question. You can see I was very busy, and a special thanks to Michael for calling me and inviting me to Costco over lunch. And then it ended up at an Italian restaurant and on and on and on, and I didn't. Obviously, everybody's Greg Wilkins, so I want to thank you for your great contribution, Greg. Anyway, I'll fix this during the first question, but I want to kick things off because I know that every single person here has been a real innovator in Comet. Every single person here has developed something that they're proud of, that they're passionate about. And not only that, every single person here knows that their solution is the best. And I want to hear if these guys are going to go out and start a new Comet project, what do you have to offer them? Why should they use your tool? You know, not necessarily why is it better than everybody else, but of course it is. But why is your solution the best? We'll start here with you, Greg.
Okay, I guess Comet D is the framework I mostly work on, although with Jetty we work on other Comet things, and even Google Wave uses bits of Jetty in parts. But for Comet D, I guess the selling features of that is that it has multiple bindings to the framework of a choice, so you don't have to say it's Dojo only. You can use Dojo, jQuery. I think there's 1 or 2 other ones coming out or have come out, plus we have Flex front ends. For the server side, there are several backends on the server side, but the Jetty one specifically, the good thing about what we have is it terminates the Comet connection or the Comet messaging inside of the servlet model. So if you're a Java developer who wants to use servlets, then inside the servlet model, which is normally blocking and synchronous, you can get asynchronous messaging happening without using lots of threads. So that's our sweet spot.
Michael.
So my biggest pet peeve with the state of Comet a few years ago, when I got started with this stuff, is that I felt like a lot of Comet implementations were trying to bite off too much. And I think having these long-standing requests from the browser, they present their own scalability problems. And what a lot of Comet implementations do is they try to have like a message queue built in. And I feel like that's also a really hard problem. And so you have these, these smart people working on the project, but there's only so many problems that they can solve. And it would be a lot better if the people who are good at scaling message queues and were passionate about that went and did that problem, and those who are interested in building Comet protocols solve that problem. And so I built a project called Orbited, which creates a separation whereby Orbited provides a socket to the browser, which then lets you connect the browser to any other backend system. So if you have a message queue you already like and already use, you can go ahead and just use it directly by sticking Orbited between it and the browser. And this allows you to always select the best of breed system for whatever your target problem is. So if you want to build a chat server, you don't say, what Comet server do I want? You say, what chat server do I want? And you find like maybe the best IRC server or XMPP server or whatever it is. And and if you're building a real-time mail application, you might use the IMAP protocol and find the best IMAP server out there. And so the next thing we did, though, is after building Orbited, we extracted the actual Comet protocol out and created a specification called Comet Session Protocol. And the idea behind that now is you can, if you want to build a Comet server from the ground up, you can read this 10-page specification, which isn't very long, and add Comet functionality directly to your message queue or your chat server without having to use Orbited. So those are sort of the two main things I've been working on.
At SitePen, we've been pretty promiscuous with regards to Comet, meaning that we've tried a little bit of everything. Obviously, we've been involved with development of Comet D over time, and we've used Orbited in various projects and Glassfish. And lately, we've spent a lot of time with Persevere, which is sort of a JavaScript database, server-side JavaScript engine, JSON, everything you can imagine possible with JSON engine, as well as Comet server. And it's very nice for getting a quick JavaScript-friendly Comet project up and running inside a servlet container such as Jetty. Probably the only thing we haven't really tried is IceFaces, at least for what's up on the stage right now.
So how many people here think of themselves as protocol developers? Right. And how about how about application developers? So with IceFaces, we're catering to application developers. We want to make it really easy for you to build push applications. Where you start is you build a JSF application, which is the Java standard for building a modern web application. Java Server Faces, that's what JSF stands for. And then you add a couple of lines of code to enable push in it. So what you do is you can invoke render passes on the server. Normally, in a JSF application, render passes are only invoked by user events. But if you want to add in push, all you have to do is say when you want a render to occur on the server, then IceFaces will figure out what is necessary to send over AJAX and update the page. We think that's a very simple way to build rich push Comet applications. And what we're going to do now is we're going to split out the push part of IceFaces so you can use it standalone. Say you don't want to use JSF, but you would like to use the push capabilities of IceFaces. It will be based on a notification system rather than a messaging system, which a lot of the other Comet technologies are based on.
I'm going to pull a little bit of a bait and switch. I work on Chrome Frame now, so whatever you're using on the server side, if you've got problems with IE, can I suggest that you try Chrome Frame?
Woo! I think the question's not really fair for Alex because he's like the only one here not pimping a product. So special thanks for Alex for joining the panel.
Chrome Frame.
How many simultaneous connections from the Chrome Frame?
And I'm not pimping a product either.
Are we not allowed to do that yet?
No, go ahead.
Well, if you all have a quick moment, Chrome Frame uses the host's networking stack, so it comes with some limitations. The reason we use the host networking stack is because it provides significant security benefits. We are subject to whatever connection limits the host provides. So on IE6, that's 2. On IE7, that's 4 or 8. On IE8, it's 8 per host. So.
Okay, good. So one of the things that stood out to me is that Ted really kind of pointed out like I'm not a I'm not a protocol guy. And I want to give Michael because I think with Orbited like he's the most susceptible to that question, right? I want to give you an opportunity, Michael, maybe to talk about a little bit more to drill down into that. How maybe with Orbited you do or you don't have to know about protocols.
Well, so this is actually a common reaction that people, they're not protocol developers, they're app developers. But the issue with this stance, so there's sort of two problems. The first is people say, okay, I want an app framework. And that's great, and people should use their app frameworks. And so you might start with IceFaces with this notification system. But at some point, you're basically sending messages back and forth to widgets in your server, and you start coming up with some kind of ad hoc protocol, right? And you start saying, okay, well, I'm going to send like this sort of notification, and then I might get this one back, and then I might send this other one. And you really just like put it together as you go without thinking it out. And if what you're building is a chat server with presence and instant messaging, then what I think makes a lot more sense is to not invent the protocol at all at any level, and instead say, well, guess what? Someone else already invented this. It's called XMPP, right? And so then you take the XMPP protocol and server that's already done for you, and you integrate that in your app instead of doing your own ad hoc protocol on top. Because unless you have software that's specifically tailored for what you want, like specifically tailored, then at some level you're adding that functionality in. And so the nice thing about Orbited is that because it's protocol agnostic, it doesn't mean you have to build your own protocol. It means you get to choose the best of breed protocol.
Mm-hmm. And Greg, let me ask you kind of the similar kind of question. In Jetty and Java, a lot of times we're working with JMS, things like that. Can you talk a little bit about how you would implement some of the things Michael's talking about, XMPP, whatever it is, and how often that's done with JMS?
Well, I mean, Michael's message of application developers shouldn't have to be worried about the low-level Comet protocols, and they should pick the best of the breed protocols. I kind of get that, except for I think as Comet developers, we beat ourselves up a little bit too much. There's of the 6 of us here, I think 5 of us said it's a collection of hacks, it's horrible, blah blah blah. But yet we just saw the demo of Google Wave happening, and there's GChat, and there's really large Comet applications that are being deployed out there, and no one's expecting you guys out there to go out and re-implement these low-level techniques to make Comet work. In some way, you can say the war's won. We've got the techniques. Arguing about which Comet protocol we like is like saying I should use Token Ring instead of Ethernet in many ways. We don't want people to have to deal with that. It's not to say we can't improve these protocols, but and there's not things that should be better. But for me, the conversation that you guys should be interested in is what abstractions am I going to be putting on top of this technique that I want to work with. Now, the Google Wave guys will have you think that the Wave document is the abstraction that you should be dealing with, and if you just program to the Wave, that it will do the Comet stuff for you. Ted's going to tell you that, or just write a normal Java Server Faces application, and we'll make this Comet enabled. Michael's telling you, just go pick your other protocol, your IMAP, your things, and we'll deal with it. And I think that's where the conversation for the larger population needs to go. Now, those people who put their hand up when they said, are you a protocol engineer? Well, we need to have a really good debate and say, can we improve these protocols and make the scalability of them happen better and make the flexibility of them happen better, and lots of things can be improved. But I don't think we need to be so much concerned about that the protocols themselves are an absolute hack. It's not a perfect world, but it's working. And because every time we say that, I think it discourages people from saying, oh, well, I'll wait until it's not a hack before I start developing a significant application. But it's significant applications are rolling out now, so time to market's everything. Start developing your Google applications and worry that someone up here or someone else will work out how to make the best protocols happen over time.
Yeah. So Dylan, we'll get back to you because Alex over there looks like he's about to jump out of his chair. He seems to at least want to echo what Greg's saying. He seems, I don't know, any comments, Alex?
I would just say that I work with a lot of browser developers on the Chrome team, and one of the smartest things I think that was said in one of our team meetings lately, which I'm not going to tell you any of the rest of, was that if you want to incent browser vendors to do something, just sort of do it, and then phrase your question in the form of a benchmark.
Oh, wonderful. Very good. Dylan, what was
I was just going to say that everything that's been interesting in the past decade is a hack at first.
Absolutely.
And standardized later. So
Absolutely.
the fact
Isn't
that we
that-
say it's a hack isn't a negative thing. It just means it's something new that's not standard or wasn't necessarily intended to be done the way it's done.
And isn't
And
that
I think that's
everything that
great.
drove
That's
Web
cool.
2.0 and
Yeah, all of Web 2. I mean, the XHR, how it came into play was a hack. I mean, it's a backdoor to get around, Microsoft's release schedule for IE5, right? So everything we've been doing that's interesting is a hack for a long time.
You remember that when asked what I thought Comet was, I replied that it's a collection of crude techniques. And the reason I say that is because the nuts and bolts of Comet, there's, as everyone's saying here, are a bunch of crude hacks. But the point is that you can build on top of that reliability. Sort of like I look at IP networks as crude hacks. Like we're just firing packets off, and like they may get there, they may not get there. Who really knows, right? And there's no ordering to them, and there's no concept of which packet goes with which other packet inside of a connection. They're completely connectionless, and it's one of the biggest hacks on the internet. It is the internet, right? But somehow we're able to build reliability and ordering on top. And so I kind of see Comet as the same thing. Like it's this low-level set of techniques for sending some kind of data to the browser, and then those of us up here have taken that and treated it sort of like IP and built a system on top of that, which is what you deal with. And so if I were to say IP is a hack, I don't really mean like stop using the internet, like shut off your Wi-Fi now. What I mean instead is like continue developing against HTTP or some other protocol. That's all.
Maybe we can just substitute the word clever for hack. Would that get us there?
Yeah, I feel like we're really expanding the definition of hack rapidly.
Just like Web 2.0.
I thought it was, yeah. We're up to 3 and 4 sometimes, depending on which room you're in. I think the smarter people are, the lower the number stays, is my opinion. So I'm a kind of a Web 2.0 fan. But anyway, so I want to switch gears a little bit, because you guys have been talking about browsers, about Chrome Frame, all this. I want to talk about where else it can be used. People are using it as a replacement for kind of SOAP. I know I did a large project, Indolo, that was on mobile. I know Michael did a game, that was all based. And maybe, Dylan, if you can talk about, using Comet beyond just the browser. Why is it a really good, strong protocol for, like, mobile devices or getting through firewalls and things like that?
Well, so, the thing that was nice about AJAX is we were conserving requests, not sending the full page from the browser and from the server to the client every time we needed something new. And Comet techniques actually further optimize that. So you're sending less data across the wire as needed, right then and there. So for something like a mobile chat application or a mobile game, because you're just sending the diffs and the bits you need to update your game or update your chat client, it's much more efficient than even an AJAX application is. So the less you have to send across the wire, in theory, the faster your game or application can be, and that's the beauty of Comet, especially on devices or networks where you're extremely resource constrained.
So Michael, I want to ask you, how long was the Tetris game up on the market?
It wasn't a Tetris game.
Well, it wasn't a Tetris game, but how long was it on the market? Can you say?
I'd rather not comment.
All right. Then the question is, what like rank did you guys make? Like, is some kind of number 11 on? There's some kind of.
I'd also rather not
All right.
comment.
It was a very impressive game. So. Anyway, any comments, Michael, on the experience of using Comet in a phone?
Sure. Well, I want to address the general question you asked, which is, what are the benefits of Comet outside of the browser? And so you have to understand that what Comet is just making HTTP requests and sort of turning them around so you can receive data back. But the important part of that is there are a lot of lockdown networks, like a corporate or government network that has a gatekeeper, and that gatekeeper is a forward proxy. And so what that means is if you have a desktop network application that has nothing to do with a browser and wants to make some sort of request out, say it's an AIM client, right? And you want to connect to AIM and chat, you can't actually do that over these corporate firewalls because all they let out is HTTP. So you can actually use these same Comet techniques inside of desktop apps to have network connectivity that goes through the forward proxy and traverses all the intermediaries. And so there are a number of people who end up doing this exact thing, building apps that are speaking over HTTP even though there's no browser involved. And so that's actually one of the use cases for the Comet session protocol that I've worked on, which is to be able to establish a stream in a mobile or desktop app that's not in a browser and still be guaranteed that you'll have connectivity.
So Ted, I want to ask you, or you can go ahead and comment on but I want to ask you about what were some of the difficulties in IceFace's implementation around kind of intermediaries. I've seen you do kind of a piece at the Java 1 and such about intermediaries.
Well, I'd like to comment first on this about
sure.
we're using HTTP requests do web services with back-end applications. And one thing that people wind up doing is they wind up polling. So they say, okay, so every 30 seconds, I'm going to check the web service and see if the data has changed. Well, what you really want is an event-based system. You want to know when the data has changed. You don't want to poll every 30 seconds. So if you have a push technology in there, you're able to notify the client that now you should go and check the web service, then that's effective.
So Ted, maybe you can talk about the different levels, such as polling, long polling, streaming, a flash upgrade, things like that, and why you have to do that, or what performance gain you're trying to get, and basically really leading into why you can't write this by hand yourself without using a framework that...
Yeah, there's a variety of techniques for implementing an event-based system over HTTP. And of course, the most rudimentary and the easiest to implement, you can put the implementation up on one slide, is polling. Say I'm going to do a set timeout in my JavaScript. I'm just going to check the server with XML HTTP request every couple of seconds. Well, that's always going to seem slow. It'll either seem slow because your polling interval is long and you don't check for data very often, or it'll seem slow because your polling interval is short and then you just flood the server with requests. So it's simple to implement, but it's not very effective. Another approach is streaming over HTTP. And streaming over HTTP, it's just a response that does not end. This might really be the best option if only we had a regular read API in JavaScript. But we don't, so it's complex to implement that. The approach that we prefer in IceFaces is called the long polling or blocking HTTP or hanging get. We heard yet another term for it from the Wave team tonight. I guess everybody coins their own term for this technique, is that you make a request to the server, and the server just sits on it and waits until it has something interesting to say, and then it replies. So you effectively invert the HTTP message flow. You're always saying, do you have any updates for me? You say that immediately, and then when there is an update, that's when the server replies, and that's when you have some interesting data. And of course, then you ask again, and you can receive additional messages.
Sure.
And just to interject
Greg,
there, just to say that none of this is actually new. These Comet techniques are as old as computers. A decade ago, I was working with Cisco trying to prevent people tunneling TCP/IP through DNS lookups, and they were doing long polls over DNS lookups. Send a request to a hacked up a DNS server, it would hold on to it until it had a packet of data and then would send it back. I assume Skype and other VoIP things, which seem to tunnel through any firewall I put them behind, they must be doing similar things. So these techniques aren't new to the browser, and just because we suddenly discovered them in JavaScript frameworks, they're ages old, and so they're standard ways of turning request response into a two-way conversation.
But it was really nice to have XML HTTP requests to have control over this.
So Greg, one of the things that you're actually kind of noted, one of the things that always comes to mind for me is your real opposition to streaming, to an HTTP streaming. Can you talk a little bit about why in Comet D it's kind of as high up at the stack it goes is long polling, and the advantages you see to that?
Well, I was saying earlier that we shouldn't beat ourselves up too much about doing hacks, but streaming to me actually really is a hack because it's not legal HTTP. So I'm all for using a protocol in new and innovative ways, and long polling does that because there's nothing in the HTTP protocol that says that you have to answer a GET request or a POST request straight away. You can take your time, think about the answer, and then send a legal response. But what streaming is doing, it's sending the start of a legal response and then putting a little bit more out and a little bit more out. And I can put a legal HTTP proxy in the way that can buffer up the entire thing. If you're running Squid or something, it'll do that. And so running a legal HTTP proxy, I can break streaming. So to me, streaming's not the best way of doing things because it works kind of mostly. And even if it does get to the client's going to buffer things up until the buffer overflows and before you executes the JavaScript. So you get horrible hacks like sending blocks of white space to make the JavaScript execute. And that's why the Google Wave guys, they probably use streaming a lot because it's probably nice and efficient when it works. And then they said they fall back to other techniques when they don't work. So yeah, of the techniques, it's the biggest hack. And long polling approaches it in efficiency in all but a few edge cases. So I just don't see the need for that hack.
And you can't really argue against long polling because really it just appears like the server is slow. And you can't criticize the server for being slow. Of course, it's being slow in a very useful way. It just waits until it has something interesting to tell you.
Yeah, you can't complain unless you're doing something on App Engine, then They complain a whole lot when you do something slow.
Or if you're using a legal HTTP pipeline and you pipeline a request behind a long pole that you didn't know it was a long pole, and so you think your request is going to be serviced as soon as possible, but the request ahead of you in the pipeline is waiting 35 seconds or something interesting to happen. So there are legal things you can do with HTTP that using long polling still trips up. And those are some of the improvements that can be done before we even go to a new protocol to try and make people aware that long poles are going through their proxies and their squids and their caches and things like that, and make sure that they get handled a little bit better.
And if you win the Even Faster Websites book tonight, Chapter 8 has a very few boring pages on this topic that I had the pleasure of writing, and so you can learn more about it. But I was going to say that I love HTTP streaming. I just wish it worked everywhere. If it worked everywhere, I would use it every day. It just breaks proxies and enterprise proxies and whatnot. And of course, we're all hoping for WebSocket, well, except for Greg and probably everyone except Michael and I at this panel.
Don't get ahead of yourself, Dylan.
I know.
We're getting there.
But,
we're getting
but
there.
the point is, there are things in place today. We have enough to do great things. We would like stuff that's better. They're kind of boring, but they are all kind of evolutionary and kind of show different perspectives for solving these types of problems.
Yeah, so Dylan had a very nice segue here into what I was actually going to do is we've been talking about the past, we've been talking about the current. Maybe the only thing we didn't talk about is common adoption. Maybe we should. But I wanted to see if any panelists had anything they wanted to talk about before we kind of shift gears and move into future specs, WebSocket, the bidirectional stuff that Greg likes, CSP that Michael likes. Is there, Ted, you look like you're... No?
Well, I don't know. Are we going to mention the current specs that have kind of come out this year that relate to AJAX, which is good in the Java space?
Yeah,
We've got
go
Servlet 3.0 coming out. We have GSF 2.0.
Well, I was going to look at Servlet 3 as like a futuristic thing, but...
It is the future, but it's now.
Okay.
Yeah.
Well, we're in
If-
final
if you
draft.
like Java,
It's like
yeah.
final draft. Ask Greg
Is Rajiv still
if
here?
it's
'Cause the final final
where's
draft
Jetty
might
8
be
at, Greg? Anyway, so anyone? Alex?
I really want to hear what Greg has to say.
Greg, what do you
which
for
bit?
which question? I think we were all yelling at Greg. Servlet. We're coming there. But Greg, why don't we go ahead and kick that off? Maybe you can tell us about your blog post when there was kind of shift of gears in the Servlet 3 spec.
Okay, so
explain that.
the quote was that the Servlet 3.0 spec is a Frankenstein monster put together of eviscerated good ideas and misdirected best intentions. Is Rajiv still
Thank
here?
God Rajiv left.
Oh, okay.
He had a family thing. He was here to field your questions, but luckily...
I mean, since that that quote and that blog, it's got a little bit better. The Servlet expert group has moved on and cooperated a little bit better. But fundamentally, I feel that the process that it's going through is a flawed process. The Java Enterprise agenda driven by a large company that's in the process of being bought, it's sort of been dumped on the Servlet spec from a great height, and now there's a whole bunch of stuff that's going into there, which really, it's all about how to configure your web app, and nothing really runtime that makes it, you can actually do anything new or different, except for the asynchronous part that's being put in there, which is rather cool. It allows you to do common applications and not have to dedicate a thread or two to every single user that you've got having a long a hanging get in your container. So there are some good things in there. Maybe a little bit more complex than I would have liked, but hey, designed by committee is designed by committee. I think we've created a lot of ambiguities in there. I mean, the expert group's still debating about what we mean by the spec that we wrote. So, yeah, the quote's not as bad as it was, but it's some parts of it still hold, and I really think someone needs to work out a better way to do specs than the JCP. So,
Ted, your best adjective for the Servlet 3 asynchronous support the spec?
I think it's great. The main thing is to have a standard that, because, okay, before Servlet 3, what did we do? We had 4 or 5 different
We had
APIs
the
that we needed to
Common
support. in it.
processor in Tomcat.
Yeah, well, Tomcat had 2 variants of push
Continuation
APIs.
and,
We had
Jetty.
the continuations, and
What did
we had
Resin call? That
WebLogic
was-
had one, which we never did. and then Glassfish has an API with Grizzly APIs. So we had all these different APIs just so that we could avoid consuming large numbers of threads on the server when we had push connections. Well, now with Servlet 3, it doesn't matter if the API is perfect or not. The fact is that it's standard, and so it'll be available on all of those app servers, which will come out eventually, I guess.
My concern is that the mechanism there is standard, and I think it's actually quite a good mechanism for doing the push. But all the other stuff we've put on top, I fear that we're just not going to get portable web apps that you can configure them on one server and actually deploy it on another one and have it work. So the actual mechanism you're talking about is good, but there's a lot of other stuff which is going to really hamper portability between containers for some time.
Maybe the TCK can sort out the ambiguities in the spec.
You'd hope.
Just test it. If it doesn't conform, who knows what the spec means? It has to pass the test.
And that's why I'm not a Java developer.
Yeah. We all
Because
love
you
the
have
tech-
no hope of anything like this in any other environment.
No. Go ahead, Michael.
So I just want to point out that this whole sort of fiasco we just heard about, which is Servlet 3 and the standards process, so that comes largely came about largely because you have all these competing containers trying to find a way to do Comet.
Well, it's not the containers that's the
sorry,
problem. I think it's the corporations.
Well,
Yes.
Alex.
wait, hold on.
Sorry.
Can I just quickly ask what the problem with that is? I mean,
Well, so-
it sounds sort of like a mess, but at the same time, I mean, they're gonna have a spec. It's probably not ideal what spec is, and at the same time, how does Orbited integrate with Django, right?
So here's the thing. We had a problem with the way that these servlets handle long-standing HTTP requests. And the reason we had that problem is because we sort of made it up, right? We built ourselves into a corner with HTTP, wanted to do real-time communication inside these servlets, had the scalability problem, and so we said, oh, instead of stepping back and taking a fundamental look at the architecture for applications, we decided to sort of push forward, as if without ever seeing how we got here, we could just sort of make it better. And what I say is, instead, what we need is a completely different architecture for real-time applications. And in particular, HTTP and writing stuff inside of these HTTP containers is never going to be a good way to write some kind of real-time chat server or stockbroker, streaming quotes, because the fundamental problem is that you're trying to build state into a stateless system and add real time onto a request response system, and the APIs just don't really match up. And so what I say, and what I've done with Orbited is, okay, let's write the HTTP parts in the HTTP container. If you have a request response style app and you want to make AJAX calls and write to the database and all that, go ahead and do that. And then when you have a real time component of your app, do that with a separate protocol that fits your use case. And I think that's the easiest way to write these sorts of applications without having to do some sort of standards by committee specification, which we didn't even need in the first place.
I always hear that HTTP is stateless, but then I have to go back and read the HTTP. Where did we not have cookies?
Well,
Is that HTTP 1.0? I don't think it's stateless anymore.
so this idea of cookies, again, is a point where we said, okay, we have this great way of fetching documents, and oh no, we want to put apps in it. What do? We don't step back and say, what are we doing? We blaze forward and throw cookies in. Great, so that worked out pretty well. For some value of now we all have it wrapped up in an API, right?
Now you get a couple of K estate, right? I mean,
But the truth of the matter is, when you write an application on the desktop, and if you look at all our desktop applications, they don't have cookies and they don't have long polls and comment responses. What they have is a very straightforward protocol where if I want to say a chat message, I just send to the server, here's my chat message, and if the server wants to send something back, it just says, here's a chat message someone else said, and we're done. We don't have to have all this complicated crap. We don't have to build these giant standards with huge worldwide corporations getting together, trying to figure out how you stuff applications into servlets where they don't really belong.
Alex?
And
I've never seen Alex speechless.
there's a couple of Stevens books on my desk that talk about the difficulties of closing a TCP socket correctly, which sort of argue that it's a little harder to do anything on the real internet, with unreliable pieces than it might otherwise be in an ideal world.
So it sounds like what you're saying is that if we have a session that's tied to a TCP socket, you don't always know the moment that that session ends, because you might not be able to detect the TCP socket being closed correctly or incorrectly or anything else, right?
I'm just suggesting that I don't know that there's a simple way out of this problem, that we will ever invent a simple, totally reliable solution that doesn't involve a protocol in which a lot of people have to agree. And I'd simply put forth that it's the agreement that's actually the valuable part about a standard or protocol. It's not that it's great, it's that everybody agrees.
Yeah, there's some crazy stuff in HTTP, but there's also a lot of really good stuff. We've built a tremendous system on it, and we have, I don't know how you'd estimate, well, you could, I guess, somehow estimate the value that we've put into building systems based on HTTP. Certainly the people attending here tonight have an interest in it, given the name of the user group. So I don't think we should throw away HTTP in order to invent a new chat protocol. I think what we need to do is we need to look at what are the characteristics of something that we expect out of a chat protocol and enhance HTTP just a little bit to incorporate those things. And
So the problem I have with this is the reason that the internet was built in layers is because it's very easy to add incremental features in different layers. But if we look at the HTTP protocol and say, oh, what does this need to be able to do chat better? And then stuff it in and say, okay, now what does it need to do stock quotes better, and stuff that in? And then like keep it up and say, okay, how about games? Like, is the latency low enough? Like, can we somehow tunnel this over UDP and then just stuff that into HTTP? You have this giant protocol, which is just like this mess that no one can ever implement.
We'd add a special thing for chat.
But that's what he's
HTTP.
suggesting that Servlet 3.0 has become.
Oh,
But no one's arguing against software layers, except for a lot of the advocates of this protocol that we haven't started talking about yet, is basically application programmers saying, oh, just give me the low-level socket and everything will be fine. I just want the low-level socket. Don't let me have any of these other layers in here. Don't put any restrictions on me. Don't say that I can only have one of them or two of them. I want as many as they want, and I want the raw iron machine because it's all mine because I'm the application developer, and get this damn restricting infrastructure out of my way.
Well,
and
I mean,
that's basically what they're saying.
Well, that's exactly what I want. But but I think what Michael's saying is that, you know, the approach he's taken with Orbited and JSIO and a lot of the other things he's done is a much more layered, in theory, cleaner, decoupled approach to building up this stack rather than trying to shove hack on top of hack on top of hack. He may have to use a hack in the middle, but he tries to hide that from his users. He tries to give them XMPP over HTTP, but you'll never know it's over HTTP other than the fact that it's in a browser, and of course it's over HTTP. So he's really tried to step back and say, hey, what would it be like in an ideal world? And I'll hide some of the ugly implementation details in as little part of the code as possible so that you're not stuck thinking about all of these things at once. You're stuck thinking about them in the right layer.
So I've got 10 widgets on the page, and each of these 10 widgets, not only they open up their own sockets to the server, but all 10 of them have their own little different hacks. Like, at least with standards, we all share the same hacks.
And just to continue saying what Michael is actually saying, I mean, I don't disagree with the fact that you want to use these layered protocols, but what I think the approaches that Michael's advocating saying is that the person who's in control of those layering is the application programmer working in JavaScript, is the one that he wants to put the layers in place because he doesn't trust the guy that writes the browser and the guy that writes the operating system and the guy that writes the proxy in between and things like that. He wants to get all those out of the way and put the control to the JavaScript.
Hold on, though. That's not quite it.
I think there's two other people who haven't said what you're saying.
Yeah,
Well, so
I think this is a really good segue, Michael, into the Comet Session Protocol.
Okay,
Because
well-
a lot of what you talk about with layers and building blocks, I think...
Let me just say that I think that the idea of layering things makes sense, and the point is, where do you add where do you expose the first layer to the app developer? And I don't want to put the burden on my operating system developer or my browser developer to go out and implement XMPP for me. Now go implement IRC. Now implement IMAP. And keep asking for more protocols. I want them to make the DOM faster and better. And I want them to spend all of their time making the best browser possible, not throwing effort at implementing these protocols. So if they just hand me a socket, or the closest they can get, then we're all software developers here. We know how to read the IRC spec, or at least there are enough people in the world who can sit down and just say, I've got a socket, I've got a spec, and now here's my library, because we write libraries. And so then it's not in the domain of the operating system developer, the browser developer, and they can do what they should be doing.
But why does the library have to be in JavaScript? That's what I don't understand.
Well, take that up with the browser developer.
And how do you do security sandboxing if it's in the application JavaScript? How do you protect the application developer from themselves?
What do you mean by protect? Like protect them from themselves? Like I don't know what that even means.
Basically, because it's I'm not working. Well, the whole cross-domain type stuff is the single origin policies and things like this is in terms of they're using restrictions that the browser puts upon them so that people don't have cross-site scripting attacks and things like that. Now, if you just have a raw socket, you're going to rely on the application developer to implement all those sort of policies. And of course, it applies on the server side as well. Are you saying that what organization is going to allow a socket that's been programmed to by an application developer, raw, unprocessed, exposed on the internet?
Well, so that'd be crazy, right? And the reason it'd be crazy is because if you allow untrusted code delivered by some web server to some unsuspecting person's browser just to like open up a socket into their internal network and like start grabbing users' mail and uploading it, you'd have a security nightmare on your hands. And so that's why we can't put a raw socket that's just straight TCP in the browser. But what we can do is start off with some kind of origin policy handshake, and once that works, then it's a socket.
So is there any conditions today where something from a browser could open up a raw socket to your application server?
I suppose there's some conditions with XML socket in Flash.
Right? Or applets? Are these things wreaking havoc?
Well, no, because they have that...
Same origin policy.
No, because they have cross-domain XML files or some kind of permission system.
And because firewalls aren't being asked to allow arbitrary sockets to tunnel through to servers. Whereas if WebSocket becomes a standard or something else is, the idea is that we're going to ask all our internet infrastructure providers to start opening up more and more holes through the firewalls so that your browser with its WebSocket can talk to your server with its WebSocket. And the people who have these firewalls are going to be asking questions about, well, can I introspect what's going through? Can I make aggregation policies? Can I do things? And if it's too raw, they're going to say, nah, I don't trust this. Everyone back into port 80, I'm only letting HTTP through.
So what we've said is it's okay for Flash developers and Java developers to have sockets, but not JavaScript developers?
No, I'm not saying that at all. I have no problems with exposing a socket in JavaScript. The problem I have is when you then turn around and say, I want that socket to be able to talk to any machine on the internet, tunnel through any firewall, and just leave the protocol to me. Trust me, I'll get it right because I'm a very smart programmer.
But no one's saying that.
Adding just a plain socket API to the browser would be fine, but it wouldn't be as useful as we might think it is because there are a lot of intermediaries on the internet, and they're not going to be interested in what we're doing with that socket.
So we're beating up on sockets a lot here, and I want to switch gears because there's so many other things coming down the pipeline, right? So many things pushing forward. And Ted, I'll go ahead and leave it up to you because you're kind of, I don't know your take. What's the next protocol? What is it going to be? Is it going to be beep? Is it going to be the bidirectional HTTP, the stuff that Greg pushes? Is it going to be CSP? Where are we going to go from here? What's your choice and why?
SCTP?
Why?
No. I think what we need is an evolution of HTTP. We want to take the ideas that people are discussing here and look at how we can augment HTTP with it because we don't need that much different. What we want is the ability to send notifications from the server.
Yeah, but
we're
you're talking about like my son's generation.
No,
right? Are we going to rewrite HTTP and?
Well, we don't want it to be a major change.
In 5 years, I want to see, something better than what we got today.
Yeah. I think we only need a few small changes. We say we add out of order replies, then we could do much easier notification type things in HTTP. And then if we enhance the fragmentation a bit so that a large message does not interfere with other small messages in the same socket, then we've dealt with a lot of the things that people are trying to go for in these other protocols.
Or add priority.
Priority? Yeah, priority would be interesting too.
So of the specs out there, Alex, are you following them very much? Or I know you've been very busy with some other very important project, but of the specs out there, do you have one that you prefer?
Well,
Because of adoption or, whatever.
I'll be a little bit disingenuous and suggest that if we want, like you said, we want things to be different by a large amount, right? I don't know that there's an obvious blessable, this is the right answer sort of a thing right now. So let's just try them all.
Try them all?
Or a very
Because
large subset of them.
I mean, earlier Greg was talking a lot about standards, and all of you guys, and I think it might have been you.
There's so many of them.
That
That's
said, it's all about agreement. It's all about, we've all decided on one thing.
but-
Now you're saying, let's try them all.
Yes, I am.
Wait a minute.
I'm saying both of those things, and they don't make sense instantaneously together. But if you think about the browser world or the network world as a marketplace of people
Cream
who are
comes
all
to the top,
competing
right?
to try to get to something that's going to allow them to individually succeed, right? We're trying to get to a good network level effect out of individual sort of profit maximization, if you will.
Okay.
Everybody wants their app to be fast, low latency, whiz bang, gee golly, and they want it to work on the most browsers. So browser vendors are going to have an incentive to go make their stuff work with the next guy's stuff because the app developers are yelling at them to do it. And the server vendors are going to have an incentive to go find a way to work with each other eventually because their customers are going to yell at them and say, I can't make anything interoperable here. Come on, give me a break. And a protocol will, assuming that there is enough experimentation and enough turnover, sort of win, and then we'll be able to standardize. And that agreement won't simply be by fiat, it will have been earned to at least some extent and then baked in. And that agreement that everyone views as legitimate, right? You can't just agree. Agreement has to have legitimacy. So there's a political problem of building legitimacy around the agreement that we would like to get to. And so I think that experimentation now and for a little while here is going to be the right way to get there.
So I think Alex is absolutely right. And in particular, I think that what we want to do is just allow all these different protocols to compete and like find the best one. And at some point, there'll be massive adoption of one of these that will win. And that's what everyone will use, right? Or, everyone will use it to the point where maybe it gets put into the web browser. But the problem is, if we sit back here in our ivory towers and say, can we predict all the different apps we might want to tunnel, like over HTTP? What sort of tie-in can we do? And we just kind of like fiat these changes to the HTTP spec, like where we sit, having been unable to test any of them, right? Because we're making this up as we go, right? We have some ideas what we might like, but it's not like we can just directly try these out across the world in all these production apps. And so the problem is that all of us up here have spent a lot of time figuring our protocols out using what the browser has allowed us to do, using like the little edge cases and the clever techniques to actually have some kind of communication with the browser. And so what I think what should happen is we should have the lowest possible level functionality given to us by browser developers that then allows us all to take our ideas and build on top of that. And it's no longer just a fight with the browser. It's more like doing like research, right? Where we actually try out different protocols we built on this low-level thing. And so at that point, we can then come to the best protocol in the wild and put that back into browsers as needed instead of just fiating it.
One thing that is happening is the IETF is waking up from a long slumber and realizing that when they finished HTTP 1.1 in 1999, that maybe the work wasn't finished. And so there's in the meeting in Hiroshima next month, hopefully there's going to be a working group convened within the IETF to look at bidirectional protocols. And so Kevin's referred to a draft protocol that I put forward for that meeting. It's not actually, when I put it forward, it's not actually I'm proposing it as a serious protocol. It's kind of like saying, well, I sat down for 2 weeks and I've come up with something that's better than the de facto standard that people were working towards, which is WebSockets. And maybe we need to take a bit more of a consideration and get the people who design HTTP 1.1, get a little bit more feedback and thought about what we could improve in it. And I definitely hear what Ted's saying, that we don't want to throw away a lot of the experience and the smarts we've got built into HTTP 1.1, and maybe we should just look at improving that rather than going to a new protocol. And I also definitely agree that we're in a phase where we should experiment with other things, because the HTTP hacks or cleverness is doing the job for a lot of applications at the moment. And people can get on and start doing their common applications now, and the standards bodies need to start waking up, and which they are doing, working towards, hopefully, in 1, 2, 3 years, coming up with some good standards. And now is the time that we should be reaping our experience, experimenting with new ideas, and having a really good debate like this, and hopefully come together in a period of time.
No, and this isn't being done in a vacuum either. Like, you make it sound like people haven't been studying and analyzing protocols for the last 10 years. There's a lot of really interesting protocols that haven't made their way out onto the web, like Beep and SCTP, where you look at some of those ideas that come from these protocols that have the ability to do framing and multiplexing within a single effectively communication stream effectively, and Greg has put a bunch of those ideas into his bidirectional proposal. So I think it's not going to be difficult to take some of the best ideas from protocols that are standardized, like Beep and SCTP, and bring that into the next generation of HTTP, and make it still compatible with current HTTP.
Given that we have a room of app developers like me, we probably don't fucking care. Really, frankly. And like every time I sit in on one of these discussions on protocols and standards, I'm the person who's in the slumber and sleep. And I say that because I just want something that fucking works, you know? Make Comet work and let me build my app.
So in that theme, Greg, you spun a new protocol. What's wrong with WebSocket, right? If we could all just agree on WebSocket, shit, we're done, right? Isn't that what Alex said?
Well, I think I basically have the sort of things I've been saying earlier about how it's too low level. It's a protocol that's come out of the applications developers need of just give me the socket and I'll build upon it. My main issue with it really is that it's hardwired from a API in JavaScript to the actual wire protocol with no level of abstraction, and it makes the application developer believes that if he says new WebSocket, he gets a TCP/IP connection underneath it. Now, even with XHR, you say get a new XHR, you're not in control of the connection that you get underneath it, and so we're giving the application developer more control. And why I can see, and you basically start an arms race, which is kind of already started with the question earlier about how many sockets can we have between a browser and a server. And some have 2, but geez, it goes fast if I have 4. Well, that only works if everyone else has got 2 and I've got 4. Once everyone's got 4 sockets, then, well, I'm going to open 32 sockets for my application because it's going to be so much faster. And I write a server.
Jetty's not going to like that, are they?
and if anything, which encourages more, I'm having a hard time keeping up with 2 or 3 sockets per user. If you're trying to put 10,000, 20,000, 30,000 users per node, and each of them's opening 20 sockets, it's not going to scale.
And the protocol needs to be sophisticated enough to handle multiplexing in order to solve this problem. So you need something that's more sophisticated than WebSocket.
So I want to take the question and kind of multiply it here and ask Michael, like, what's wrong with bidirectional? What's wrong with WebSocket? And why CSP? Last night, emailed, or maybe last night, something like this, emailed all the panelists and said, hey, look at this new protocol I've rolled. Because I know Beep, I know WebSocket, know of them, familiar with them, and here's something better. Here's a building block that we can build on top of. What are some of the things that CSP is doing that other protocols out there aren't?
So the first thing, CSP is a protocol that isn't looking forward into the future to say, what do we eventually want? Like, what will browsers become? What CSP is a protocol that operates right now in browsers over the intermediaries that exist today. And there are 4 server implementations already completed and working in production. And there are 3 more underway. There's Python, 2 in Python. There's 1 in Ruby. There's 1 in Erlang. There's an alpha version in C. And there's 2 different clients. And so the point of Comet Session Protocol is while we're all up here debating what the future is going to be, you can just sit down and open up a Comet session with a server and send data back and forth. And your API is send and receive and open and close, right? And you're done, and that's it. And so in the meantime, I view these discussions as a way of figuring out how to eventually have something that optimizes that so we don't have to do so much of it ourselves. Now, the thing that's interesting about this whole discussion, though, is as soon as we start talking about these higher level features, like we start talking about multiplexing, we start talking about framing, that's where the disagreement starts, right? Like everyone up here, I'm pretty sure agrees that we want a way to send data to the server and a way to send data back to the client, right? Like those are 2 things we want. Okay? So if we agree on those two characteristics and nothing else, then why don't we go ahead and add those two characteristics to the browser, right? Add the ability at some low level to send data back and forth, and then we can implement multiplexing, and we can implement framing, everything else as a protocol on top. And if people really think that this is a pressing need, that their mashup that has 100 different little widgets on it need to use some kind of multiplexing protocol, then they'll go download Greg's multiplexed framed protocol and use it. And I imagine a lot of people will, because it'll be necessary for those sorts of apps.
But we have the capability today. We can send data from the server to the client. We've seen the demos. So, why do we need to do anything else? Game over.
Because it's expensive, it's not prioritized, and it's not secure.
Well,
And we need the ability to put that in.
important, like the fact that maybe Orbited does streaming, and so it can have in some certain edge cases up to 3 times less latency than a framework that only does long polling. So you're sitting there trying to come up with some sort of decision calculus based on all of these like random low-level facts, when really what you want to be knowing is, like, does it support multiplexing and framing and these higher-level features? You don't want to worry about all these transport-level features. So what I'm thinking is we should have something like WebSocket, which gives you the ability to send and receive data in the browser. And once you have that, you can choose what protocol you want on top based on its functionalities.
So we've been banging at this for an hour. Can we get to questions?
Here.
Sweet.
All right. So Greg seems to think that the lack of direct control over XHRs and how they relate to HTTP requests is a major benefit. And I'm curious if any of the panelists know about problems that might have caused for Comet applications in developing Comet.
I alluded to one earlier in terms of if you do an XHR request, which is a long poll, and someone else in the same browser, potentially in a different application, a different tab, different window, does another XHR to the same host, then that request can be pipelined or queued behind your long poll. And so you can get weird delays and things like that. So there are definitely problems that need to be resolved, and there are some proposals for some short-term fixes to HTTP to identify long poll requests and things like that, so browsers can be more intelligent about not queuing behind. But yeah, so there are problems with it.
But browsers tend not to do that because they don't really know about pipelining very well at all.
Exactly, and so pipelining was a really good idea to try and do efficiencies, but it hasn't really taken off a lot, can only be used in very limited circumstances. And sometimes I feel like, the WebSocket advocates are saying, well, just give me the socket and I'll do pipelining of my messages better. But all the problems that make pipelining in HTTP not work are still present in WebSocket. If that socket just suddenly closes because the other side idled it out, I don't know if the message I just sent was actually delivered or not. There is no orderly shutdown of a WebSocket. So therefore I have to say, well, do I send it again or do I just send it again? But with HTTP, at least you know whether it's a put or a post or a get, so you know whether it's idempotent or not, so you know whether it's safe to retry or not. With WebSocket, you don't know. It's just, there's no metadata about it. So it's a real step backwards in these problems that we're having today.
I really feel like the book we should be giving away this evening is Richard Stevens' TCP/IP Illustrated fourth edition, second volume.
You just
So-
win the conference pass. Can you come out?
So
and put your
one
name?
thing I want to point out, just so everybody knows, Frank is also easily could be on the panel, and he's one of the real innovators at Comet as well. So anyone who asks a question, we got a few queued up here. We got some passes, so go see Bess and give her your information, and she'll get you hooked up with the conference pass. Another question.
What I guess might be called a dumb question, but I'm not even quite sure what Comet is. Is it a word that wraps things like long polling and prioritizing on the server and stuff like that? Yeah. Is it, there's no standard or
Yeah. So Comet's an idea. It just means pushing data to the browser. Here we go.
I saw the slide, but it's
So I say it's pushing data to the web. Greg, it's crude techniques for pushing data to the web. It's a collection of hacks for pushing data to the browser. It's really, AJAX is very popular because it allows a browser to say, hey, I want more data from the server. Comet is the opposite, sometimes called a reverse AJAX, where it's actually letting the server say, hey, I'd like to push something to the browser. So it's the server determining when to push that data. So HTTP is sort of a connectionless protocol.
I understood that point.
Unless
but
you read Alex's
I
book.
was trying to understand if there was a technology behind it or something. And it is.
It's really just Alex's spoof of the word AJAX.
I
Is
was wondering,
another
is it a-
comment
is it
clean,
another cleanser?
It's another cleanser.
another
yeah.
cleanser, but it's just to describe basically things that are faster than AJAX.
And that's the danger of this panel, right? Because here we are, we're arguing about these underlying protocols, and this is really important to us because we're all developers of AJAX frameworks. But likely you're users of AJAX frameworks, so we've insulated you from all of this. You can just write your push application with push features in it, like a chat application or what you saw demoed in the Google Wave, and you can use those features.
This is totally Jerry Springer, right? Like, you can go home and be like, I'm so much better than those people.
No. See, the real problem is you're looking at the elephant from one point of view, and we're all blind wise men. But the problem is, the reality is, people have already decided to expose a lot of the services that people are worried about. There are compelling cost and performance reasons why that discussion is over. The other reason and the problem people have to understand is that there is Darwinian right now decisions about protocol standards, frameworks, and things to handle these stuff. And by exposing them in a modular, from old programming best practices way, and let people pick and choose and put together the best ones, you will have safety and security. And
Questions,
I say
Green.
this.
Questions.
All right. So
That was an
you're right.
answer.
You're right. I have to get that out. I have to get that out.
Leave the
I have to get that out.
comments
Thank
to
you.
the
Thank you.
There's
So
an
the
extra
question
chair,
is,
yeah.
how do we see and where are the problems with us actually, realistically, getting consensus by excellence on these? That's what I need to see. Because, right, I remember in the days when I was a guy, we had apps doing this crazy shit. Excuse my French.
We have, so the point of view you're advocating is that distributing totally conformant, interoperable implementations of protocols is cost-free.
No.
So,
It's less costly than what we have otherwise.
okay, so that it's less costly than we have otherwise. We have a lot of experience with trying to distribute. Software lives a long time, right? It lives a lot longer than any of us hope it will, usually when we're writing it. And so I suspect that the trade-offs will get made differently for different applications. And so where the design center is seems to be unresolved. And you're advocating for a design center that says JavaScript is cheap, I can run a lot of it, I can update it frequently, I have a lot of control. I know of a lot of large applications that aren't quite so blessed.
No, I'm not saying JavaScript. What I'm saying is people are going to choose, and you can't make it so that it's idiot-proof. I mean, programming is not an idiot-proof situation. You can't make it so they can't. You can't make it idiot-proof. I know the Microsoft guys are trying, but it's not going to happen. So you're going to have to let people learn by pain and trial and error, which is what the internet's about anyway.
Right, so basically networks suck more than operating systems, which suck more than browsers, right? So give power to the easiest.
Yeah. So, next question? Go get a pass.
So one of the key things which is underlying a lot of the comments being made is it's all about port 80 because we've got port 80 open through firewalls into corporate networks and home users and these kind of things. And making connections from outside the firewall in is hard because you can't make that connection. The connection can only go from the client out to the server. And we hear there's been a lot of discussion about layering protocols on top of this and WebSocket, this kind of thing. But to me, it raises the next level issue, which is, and I'm from Alcatel-Lucent, so I look at this and I go, well, okay, now everything's over port 80. Now we got to go back to, why did we have ports in the first place and different kinds of traffic and different ports, and why did we shut off ports? And now you've taken all the control out of the administrator, so now we got to do more deep packet inspection and identify the traffic, and now we're in an arms race of people putting data on the wire over this port, and we have to identify it.
And you get to sell so many more boxes.
Sure, but what I'm saying is, and I guess I'm looking for the comment or the insight is, wouldn't it be better to tackle this problem as a port 80 problem? And how do we open up ports for classes of traffic and kinds of traffic so that these things can work together? And the secondary point is, the reason we're all so focused on the browser is because that's the default client of port 80 today. But if we opened up these ports and allowed traffic to go through, well, maybe it's not the browser. We look at things like augmented reality. Well, the client may not be a browser.
Well, I'll go back to my last answer, which was that networks suck more than operating systems suck more than browsers. And what I mean by that is there are a lot fewer people that understand networks and how to administer them and how to optimize them. So the default answer is no.
And my answer is this is why we want a small evolution of HTTP, because we already have all this infrastructure in place. You don't want to have to explain to all the administrators in the world why there's this new protocol that is unlike anything they've ever seen that they have no way to inspect the packets for.
But you should also consider why they're inspecting packets and why they're blocking ports. And you can imagine you have some government facility that decides, well, we don't want people chatting on AIM, and so they just like block off all those ports, right? And so then Meebo comes out, right? And now it's suddenly in the browser, and people are back on AIM. And then pretty soon, all of these apps are like in the browser over port 80, tunneling over HTTP. Then we get together and say, okay, we're going to standardize some HTTP-based protocol. And now the intermediaries can once again, analyze that traffic and see like, oh wow, we're really just running chat over HTTP, and then block it again. And as soon as that happens, well, what do? Like, we figure out some new way of tunneling, right? So it's just this weird arms race is what it comes down to. And I think I think it's a social problem. Well,
it's an economic problem, right? Everyone's just cost shifting. Everyone's saying, what can I do today to make my thing work, right? Network good neighborliness be damned. And they're not wrong to do it. I think if the question is, how do we encourage large organizations, say enormous-sized ISPs, to open up more ports out of their traffic, do it in non-discriminatory ways. I know there is some lobbying going on about that kind of regulation. That might be one way forward.
And the thing is, it's a door you can't close. I mean, if you can do DNS lookup, you can tunnel data out by setting a name, and you can get 4 bytes back and an IP address, and you can tunnel data out, and people will tunnel data out. And so there is, as Michael was saying, this effort to channel everything through port 80, and so there might be government bodies that want to censor things that's happening in there, and there's social responsibility things and social problems there. But I think part of the issue is if we can make normal traffic look a little bit more normal, and help out the fact that there are reasons that people want to aggregate through port 80 or filter port 80 or do things, and and make sure that what we're going to doesn't look like Mr. Evil Guy tunneling through DNS. Then asking the network infrastructure people to be a little bit more flexible sometimes, and maybe let a few other things through rather than just slamming the door shut whenever something looks a bit strange, we might get a better response.
So I really like the ideas of trying out all those different ideas and techniques. And I already raised my hand. As this software system and hardware is evolving and see which one sticks the longer, do you see lights in the end of the tunnel here as the CPUs are getting to multi-core and many cores, and perhaps we could really get what we want on the multiple sockets, multiplexing and frames. Do you see as the hardware evolves into multi-cores, the browser is getting better in handling this?
The answer is no. I don't think there is ever a light at the end of the tunnel. Like, I think it's sort of like you have to find meaning in the struggle, right? And we're all going to die at some point. And so, in the meantime, here we are making our meaning.
Well, I think with hardware evolution, it's what's interesting is as hardware is becoming more powerful, browsers are becoming more powerful, and finally, say with Google Chrome, we see operating system concepts being applied to a browser, which was brilliant. I mean, having your plugin crash and take down the whole browser is really annoying, but it doesn't have to.
I have a question that kind of builds on those last two. I'm wondering about scalability. Where do you see the bottleneck right now? Is it the pipe from the user to the server, from the server to the data? Is it the data server? Is it the front-end server? Where do you see, maybe where is it at now, and in the future,
Yes.
where do you think the bottleneck will be?
Yes. No, really, it's all of them. It depends on the scenario. So it depends on what you're trying to scale, how you're trying to scale, what the network's like, what kind of data you're trying to send, how many users, how different the data is between those users. There's so many different variables. Yes, it's all of those things.
But one of the most basic scalability limitations people have run into with Comet and push applications is having to sustain very large numbers of connections that remain open. Because normally in a web server, you don't have a lot of open connections that just sit there. So being able to handle that in a with a small thread pool was important, and that's where the asynchronous features of Servlet 3.0 came in.
It's also why pretty much none of the popular Comet servers are the same as popular traditional HTTP servers, because they're really, like an HTTP server is open and close as many requests as quickly as possible, whereas a Comet server is sort of optimized for perhaps fewer but longer-lived connections in general.
And I guess the thing is that the sort of class of application we're opening up has vastly more data available than we can ever possibly dream of streaming out. I guess one of the classic examples of a common application is a streaming a portfolio, a live portfolio, so your share price changes. Well, a share price, something like Microsoft, is going to be in a lot of people's portfolios. It's going to change many, many times a second. And if you've got 20,000 users connected to your server and Microsoft's price changes 100 times a second, you're not going to tell them about it all the time. And so there has to be, it's not, the solutions for the scalability is not a protocol issue. You can't fix that problem with a protocol. It's designing your application so what you're telling out to your users is something that's going to scale.
So I kind of have the silly question. Why not have a browser plugin, say open source, that could open a socket and then fall back to Comet? Silly question. I just kind of want to.
Well, I always hoped Gears would do that, and now there's this thing called Chrome Frame that could do that. I guess maybe, not really, maybe.
It's called Flash.
Now you're trolling. Yeah. Flash already can open a socket, and it's in all browsers. I mean, it's exactly right, Greg.
Got a question. Is a comic sensitive enough about the end user's bandwidth so that it won't create a denial of service kind of floodgate? And the other thing is, along that line, if we don't want it to, say that we only want to have 20% of data coming in so that I can do something else. I mean, is this possible, or is kind of not on the mercy of server?
The HTTP generally doesn't have that much visibility into the overall sort of running average network load and available bandwidth. I mean, from the browser, right, where the stuff is being implemented today, we just don't have a way to try to provide quality of service guarantees to the requests that you're making. And I know that questions like ordering and priority are definitely sort of like the kinds of things that Greg's talking about with small additions to the current HTTP in browsers to say this is not as important as that other thing are designed to potentially allow us to provide that kind of information. I need a duck, I think.
Apparently, Kevin's really bored of this panel. He's giving out this swag before we're done. What the fuck?
Yeah. The shirts are in different sizes.
Question. Yeah, go for it.
So is there only one? Do I have it?
We can't have single servers deal with that. They solve that by distributing it to where the resources and the performance is going faster than on one server. Because that's the issue. One top person can't run all this and handle it on all the networks.
So I'm curious. So we're relatively new to Comet and wanted to hear how you guys are doing your unit testing.
Well, so the in CSP, for Comet Session Protocol, which we're using in Orbited, we have a spec, and then we've created an acceptance test suite because we think an acceptance test suite is better since we have so many different server implementations. They'd each have to do their so each server implementation does their own unit tests, but then this acceptance test suite runs on its own, connects to the server, sends data to it, expects certain responses. And we have almost complete coverage of the spec.
You're doing like mock requests. Are you using Selenium? What are the
well,
tools
so the
that
thing
you're
is,
using?
as far as the server is, so there's two questions here. One is in the browser and one is in the server.
I think he's asking about the app.
Oh, you're asking about the application itself. How do you do unit tests for an app?
How
using
do
Comet?
we application programmers what should we do? Yeah.
So,
what tools are you using? Are you using Selenium? Are you using mock?
We use Selenium to test IceFace's applications.
Okay.
Selenium is sort of weird because it itself is doing long polling Comet stuff in order to.
So I want Greg to answer this question and talk about one of the things that Greg told me is one of the biggest problems or something with common applications when they look at scalability in Jetty is that the test client that they write is bad. So Greg has a nice tool.
Okay. I was going to say a couple other things first. I mean, in the Comet D download, when you build it with Maven, we actually run it up in Rhino and do our unit tests in Rhino. So we run our clients against that. So on the server side, we have a Comet D client written in Java. So we can fire up again, inside a normal Java unit test and do real unit testing. The problem with Selenium is it's kind of way above unit testing. It's integration testing. So you can still do all this with unit testing, quite small components, by mocking up the browser in Rhino or mocking up the client with a Java client. And I guess what Kevin was alluding to, that one of the problems we've actually had with testing these things is you say, okay, I want to do a Comet server and it's going to have 5,000 simultaneously connected users. Well, the problem is if you get your average HTTP connection tool and you open up 5,000 simultaneous requests that are going to be long polls or held, that the testing tools fall over. And so the testing tools can't actually, because most of them allocate a thread per simulated test user. So we actually we invented the Java Comet D client because we could use the asynchronous techniques of Jetty to have an asynchronous client that could then do the Comet D protocol. So we can simulate 5,000 or 10,000 users from the one load generating machine.
I have one question. Okay. Is perhaps, I will be fussy, it's mostly an historical question, but the background is this. I work in a project where on one side we have network management, managing solar cells, devices, and on the other side we have